here, here, go here, 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 go here. Two. That made no sense. Change this thing. Okay. I have no good grades and this. Here it is. Okay, literally 0. See. I don't know what that sound is. Huh. Okay. I will start my stream, even though the students are not on. It's okay. We will start because there's already a delay of like 10 seconds. Okay. Today we are talking about limits, and essentially we're looking at the limit concept presented in chapter 12. We are going to be going through it rather slowly, so we'll break this section, this one, into two parts, and then for 12.2 we'll do it in one section. Yeah, one section, and then 12.3. I'll talk about it in 2 parts, even though it's shorter. And then 12.4 in 2 parts. It's kind of my goal. If that works. Actually, no, 12.2 we'll do in 1 part. 12.3 we'll do in 2 parts. So that will be my plan. Okay. 12.1. Here we go. Back to that section. Okay, the limit. So the limit, I'll just blow up the screen so that it's actually visible. This. Okay, so let me take one. That's roughly 10 seconds. Okay, that's a delay of 10 seconds. Okay, so let's zoom in a little bit. Close all these. Zoom in. There we go. Wow, that took almost 20 seconds. Okay, the limit concept in calculus, there are 2 types of uses. And this is actually crucial. So the tangent line problem, or you could say slope / derivative. So slope / derivative, or the area problem. And the area problem is also known as type I, or Okay, antiderivative or integral antiderivative. Oops. Oops, I didn't put the gives on in. Okay, antiderivative. So the limit concept of calculus, this is going to be the single most important lesson facing us in order to prepare for calculus. So what I often said was, you can do this if you want, but I won't put it again, micrometers. Okay, example number 1. So we're going to talk about example number 1. So you are given a 20 inches of wire. Form a rectangle whose area is as large as possible. Determine the dimensions of the rectangle that are reduced. So you are given 24 inches of wire. That implies that's our perimeter. And we need to make an area as large as possible to determine the dimensions. So what we're going to get is a sort of triangle. So we're going to move over to our to this graph. Okay, so we have 2L plus 2W equals 24. Okay, that's the perimeter is 24. Now, area equals length times width. You guys, we've done this problem in Algebra 1, Algebra 2. Okay, and then you're going to solve this for L, so we get L equals 12 minus W. So plugging it in, we get 12 minus W times W, so we get 12W minus W squared. Now normally, you would set this up, find out what A is, plug it in. But since we don't have an A, we actually have to use limits. So we would create a table in this case where we have our width and area, A. And we're going to kind of see as we approach as we get closer and closer to 6, what happens with our area. So, and then as we get further away, what happens to our area? Sorry, it should keep going. So 6.5. Both sides should be about the same. And 7 over here. Okay. So plugging it in here, we'll plug this in. 60 minus 25 is going to give us 35. 0, 0, 5.5. This is just going to give us 35.75. We're just plugging it in. 5.9 is going to give us 35.99. If we look at 6.1, if we plug that in, we get 35.99. 6.5 in, we get 35.75 and 35. So we find out that 6 is actually going to be our max. Our max is going to be 36. So we go up, and then after 6, it goes back down. So then, if we were to write this as a limit, what we'd get is, so we would write limit as W approaches 6 of 12W minus W squared would be equal to 36. So this is an area problem. Basically, as we get closer to 6, our answer, our function, should approach a set number. It's kind of like as our x value approaches something, our y value has to approach something as well, or so we think. Since we're splitting this up right now for this lesson, it is in fact that it will approach a value. Okay, so we can do this kind of problem. This very area problem is going to be doable. So you make a table for this one. Okay. Now, definition of a limit. Let's blow this up so that you see it. Sorry, take a second. Here, go here. Okay. Okay. So, if f of x, so f of x becomes, now this is actually like, to explain this vocabulary, this is actually mathematically exact. Arbitrarily close to a unique, this is unique number that's bolded, not bolded, italicized, L. So if f of x becomes as, obviously, x, oops, as, let's do this, as x approaches some number c from either side. So this has to be either side. The limit of f of x is as, so the limit of f of x as x approaches c is F. Okay? This is written as, okay, you write the limit x approaches c, so the limit as x approaches c of f of x will equal f. Okay? So the limit as x approaches c of f of x equals f. So, a few key definitions. Arbitrarily close. So, arbitrarily close for all of us, think be close means that there is no number between f of x and L. Okay, there's no number between. Arbitrarily close means you can't stick any number between. Unique number means it can't be more than one number. So the limit requires one unique L. Then C from either side. This means from the left side of the graph and from the right side. Notice on our table, if you remember our table, we went closer to 6 from both the left and right side. That's crucial. Okay? This is like, this is the heavy hitter. This is the meat of the potatoes. I use meat potatoes for some reason all the time. Okay, so again, left and right side approaching this number C. Okay, this is our C right here. We're looking at what this equals. Now, next class, and as we go, we'll get more straightforward. Okay, so we're gonna just plug this. So right now, we just plug these numbers in to x and solve it for f of x. We're gonna do it from both sides, and then we will do what 2 would equal. Okay, you can estimate. Okay, as we get closer. Okay, so 1.9. If I plug it in for x, my apologies, I'm looking for a calculator that I must have placed down. Okay, so I'm going to plug in 1.9 for x into my calculator. I get 3 times 1.9 minus 2, and that answer is going to be 3.7. So 3.7. And the next one, plug in 3 times 1.99 minus 2, 3.97. Then plug in 1.999 minus 2, and I get 3.997. Now, normally you'd be able to predict what this is getting close to. So what are we getting close to after getting close? Well, but it has to approach from both sides. So we do it with both sides. 3 times 2.1 minus 2, and this is going to be 4.3. And you might be like, well, these two are different numbers, right? This number over here, so this number and this number are different. Well, you're going to see something of a symmetry here. 2.01 minus 2, 4.03, 4.03. And if we plug in this number, 3 times 2.001 minus 2, we get 4.003. Okay, now looking at this, notice how this is getting small, this 3 keeps getting smaller and smaller, and this keeps getting closer and closer to 4. So this keeps getting closer and closer to 4 by going down, this goes closer to 4 by going up. So then we can estimate that this is 4. And in fact, we are correct. Okay, so I'll give you a minute to plug in this one, try this one out, same process, okay? Try this one out. You just plug in 1.9, 1.99, 1.999, 2.0, anyway. Plug these in, and then solve for f of x. After you get these, estimate this, okay? I figure, okay. Okay, so you plugged it in, and you should have gotten. Here, let me turn in my book because to save time, actually time. Okay, so you should have gotten 13.5, 13.95, 13.995. Here you should have gotten 14.5, 14.05, and 14.005. So as we can see, from both the left and right side, it's getting closer to the number 14. And in fact, as we will learn, that will be our limit. Okay. As we will learn, as we go, we'll learn this number. Okay. Now this one, if you plugged in 0, would actually be 0 over 0. If you just plugged in 0 into x, you get 0 into 0, which is problematic. But if we see how it approaches from the left and how it approaches from the right, we can estimate what the answer is. So let's plug this in. So negative 0.01. Okay, so we get we have negative 0.01 divided by, and then in we have negative 0.01 plus 1 minus 1. And this would equal 1.995. Okay, we'll do 1.9. Okay, and then we plug in this in, you get negative 0.001 divided by negative square root of negative 0.001 plus 1, and then that whole thing minus 1, and we get 1.999. Let's just do this for the sake of showing progress. 4. And this one, plug in negative 0.0001 divided by negative 0.0001 plus 1 minus 1 equals 1.99949. Okay, same direction, so 0.01 divided by 0.01 plus 1 minus 1 to the 2. Sorry. And this is 2.0049. Okay, plugging in 0.001 divided by 0.001 plus 1 minus 1 square rooted 2.0004949. And the last one, plug in 0.0001 divided by square root of 0.0001 plus 1 minus 1. And our answer is 2.00049. Okay. So if you notice something, we're approaching what number from both left and right? Well, what number are we approaching? We're approaching 2. Now, would that be clearly obvious if we plugged in 0? No, because 0 divided by 0 plus 1 minus 1 would not give you a clear answer. Okay? So it wouldn't be clear by just plugging in. This is why we're doing this table. Now later, there's an easy way of solving this, but it's not clear from the beginning. Okay, and nor should I expect you to know it without a table. So, do we have to make a table? Yes. Is that going to be okay? Yeah. Okay. This one, same issue. If you plugged in the 3, top and bottom, you would get 0. So, what we do is we're going to plug in these numbers from the left and these numbers from the right and see what it approaches. Okay? It's a very short lesson. We should finish actually after this, do this problem, and then we'll be done. So we're really only doing half a lesson today. Wednesday we'll do a full lesson of the rest of the lesson. And beyond Wednesday, we'll keep up the schedule of doing a full lesson so that there'll be time to review. Okay, I'm gonna just plug it in. Okay, so you get 2.9 minus 3 divided by 2.9 squared minus 9. You get, answer is 0.169. Now, I could go further, but we're just going to start there. Then we plug in 2.99. So, 2.99 minus 3 divided by 2.99 squared minus 9. Your answer is 0.1669. And then if we plug in 2.99, 2.999 minus 3 divided by 2.999 squared minus 10 parentheses, and that gives us 0.1666. Now we don't know for sure what number we're approaching, but let's see from the right side. So we did the left side, now let's see the right side. 3.1 minus 3 divided by 3.1 squared minus 9. And we get 0.1639. Interesting. What about 3.01? 3.01 minus 3 divided by 3.01 squared divided by 9. Oh, well, minus 9. That's definitely the wrong way. So this is 0.1663. And this is an 8. Okay. So plug in 3.001 3 divided by 3.001 minus 9. Oh, squared minus 9. We should get 0.1663. Okay, so what number are we approaching as we go this way? Well, this would be approaching 0.16. Let's see if this works. Let's do this. 0.16 to the 0.16. Just know how to But 160. Got it. And are we correct? Great question. Are we correct? Well, let's see the example number 9. And it says error. So first thing we need to know is, can we plug in this? No, we can't plug this number in. So you would say, so our answer would be, our answer would be no, can't plug in 0. So it doesn't, so you can't plug in 0, but the answer is 2, okay? So the limit is 2. Same thing over here, you would say, no, you'd say no, but the answer is 1 over. You'd say 1 over 6, or you'd say 1, 6. I don't know how to write this any other way, so I'll do it with that. Okay. Now, doing this with graphs, so I'm going to pull up my decimals. Okay. So start graphing. And you can do this limit by just graphing the function y equals x cubed minus x squared plus x minus 1 divided by x minus 1. Okay? If you notice, okay, we're going to do the limit as x approaches 1. We're going to zoom in. Here's 1. As we approach 1, we're going to see we're getting closer to something. Okay, approach 1, we're getting closer and closer to 2. And notice, it is undefined at 1. There's a hole there. Okay? If we go down from the right, we're getting closer, lower and lower, closer and closer to what number? 2. So as we get closer to 1 for x, we get closer to 2 for y. And then again, does it exist? No. Okay, so that's how we do that. Okay, so we're going to turn off that graph. And our other function is going to be piecewise. So let's see if I can do this. X equals 2 and x. Trying to find out where not equals is. Hold on, let me open this up for a second. Hold on, let's see if I can go piecewise in this. Gotta find my piecewise function. Well, they don't give me piecewise, so I'm just gonna make 2 graphs. Okay. Fortunately, but that's how we have to do it. Okay. So we have y equals 2 and y equals 0. But this is when x equals 3, 3, and this how do we do this? Okay. Okay, I don't think we can do it. So I can't do domain. Okay. I can't do domain. Maybe. Okay. I think it. So so it's not. So it skips 4, 5. Okay. Set this one. Let's do 2 for this one. Just at 3. Okay, so this is sort of how it goes, but essentially there's a hole right here, okay? So there's a hole right here, but left and right are the same number, 2. So even though there's a gap right there, in this piecewise function, there's a clear limit. That is, as f of x will equal 2, okay? Let's do this official when x approaches. That doesn't work. Sadness, we can't do the limit the way I want to. Or rather, I have to use this stuff right here. So as x approaches 3, we have f of x equals 2. Okay, same thing over here. As so the limit as x approaches 1 of f of x, we will get f of x will equal 2. Okay. So they both give us a unique number as a solution, so we can trust our graph. Okay? Okay. And that is our lesson for the day. Okay? Very short, so our homework will also reflect that short, brief period of time. Thank you for joining me. I know no one joined the lecture, but hopefully you'll still be able to learn it on your own without having me give you feedback. Okay, we'll do the lesson next Wednesday. Okay?